Hello, all you pre-calculus learners. What we're going to look at today is how to classify certain types of discontinuities. There's three different discontinuities that you need to know. We're going to go with number 1, number 2, and number 3. All right? So the most common I'm going to say that you're going to run across is infinite discontinuity. You know what? I'm not going to spell discontinuity because it's right there. All right, but I'll just try to spell infinite neatly. All right, infinite. All right, infinite discontinuity. And that is always when you're dealing with these things called vertical asymptotes. When you see vertical asymptotes in a graph, you know you're going to have some infinite discontinuity going on. All right, then next thing we're going to talk about is removable discontinuity. Removable discontinuity, and there you're looking for holes, also known as point discontinuity. All right, so you're going to have discontinuity at a point. And then last but not least, you got these things called jump discontinuity, you know, like the old Van Halen song, jump, jump. Got it. All right, actually that's crisscross on that one, but the other one is the cool synthesizer song. Dun 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 dun. So if you haven't watched that video, you had to endure that right there. All right, so we got vertical. Now this one has no vertical. All right, none whatsoever. No asymptotes that I can see. It does have a little jump discontinuity right here. And how can you tell jump discontinuity? Well, if you're just kind of tracing it and you have to jump from one point to another, that's called jump discontinuity. And here we got removable discontinuity. So right here at x equals -6, we got removable. At x equals -3, we got jump. Let's see what this question's asking about. Okay, it says select x values which has removable. Well, I only see one. It's going to be right here at -6. That's a removable. Oh, hold on. See if I can. There we go. Removable. X equals -6. Boom. All right. Ooh, I see some infinite discontinuity going on right here. Okay, so right now we do have infinite discontinuity happening right here at x equals -1, we have infinite. We got some removable discontinuity, so we do have input. We got RD, removable discontinuity, at x equals -7. We've got some infinite. All right, put I and F, infinite, at x equals -1. But I don't see any jump discontinuity going on here. I don't see none. I'm sorry, I don't see any jump discontinuity at all. None whatsoever. So we'll look for none of these. None of the above. Okay, all right. All right, ooh. I like that graph. That's kind of a cool graph. So I'm going to take my snippet tool real quick because I like to see if I can snip it here. That's a good looking graph right there. I might use that later. Snipping tool. Let's snip it. Okay, and then I can ask my own question on it. See here, file, save as, and let's go to all of my cool little pictures and look for some discontinuity graphs. All right, we'll just call it discontinuity number, that's 5. Let's call it discontinuity 6. Yeah, I like it. I like that graph. All right, let's go back to minimize this. Okay, so on this one, let's go ahead and label a couple things because we got infinite and we got jump. Sweet. Okay, so we got some infinite discontinuity going on. Infinite is right here at x equals 4. We got an asymptote, so it goes up to positive infinity forever. Then we do have some jump discontinuity going on because you can see going down, you got to jump down here. So that's going to be at x equals -2. And then we're going to use this opportunity to kind of talk to you guys about limits at points. Okay, so for example, if I said, what is the limit of f of x? What is the limit of f of x as x approaches -2 from the left? So by that little negative sign means from the left. So from the left, it's approaching 0. But interestingly enough, if I say, what's the limit of f of x? What's that? What's the limit? What's it going to approach as x approaches -2 from the right. Now, as I'm going from the right, now, what's the limit? It's approaching at -3. So you kind of need to know kind of what this means. All right. So anyways, just wanted to let you know. We don't need that right now, but you might need it later. Right now, we just need to know where there's jump discontinuity. And there's jump discontinuity happening at x equals -2. And then last but not least, ooh, another good picture. Let's see if I slide up here. That's a good picture right there. I like it because we got a couple of vertical asymptotes happening right now. All right, and so I'm going to go ahead and do another snippet real quick. Won't take long. New. That's a good looking picture. And we'll call it Discontinuity 7, huh? Yeah. You never know, I might have already done it, but oh well. All right, let's close that out for now. All right, so now we got, looks like we got a jump discontinuity here. We got infinite, and we got infinite. So we got two infinites and a jump. So I've got an infinite at x equals 1 and at x equals 5. All right, so I got infinite at both those. And then I got a jump. Dun, 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 at x equals -5. Dun, 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 dun. All right, and we're going back to the 80s for jump discontinuity. What has removable? I don't see any removable discontinuity. Just because that's a hole doesn't mean that's right. I mean, that's the jump discontinuity happens like right here. Here is where the removable discontinuity happens. Ooh, that's a good one right there. I better write that in real quick. Oh, I already put it right there. Removable discontinuity at -7. So that's removable, but this is going to be jump. But there's no removable. There's just no removable. So if there's none, then we just say there's none, and we call it a day. All right. That's how easy it is. I hope you guys have a good time classifying discontinuities. There's only 3 of them. Good luck. Have fun. Let's call it a day.